still lean.
Yeah.
6 7/8, right? 7 1/4.
Yeah, but see, you can hop curbs with this thing.
What's the difference between 6 7/8 and 7 1/4?
3/8
and 3/8.
3/8.
3/8.
Inch and 3/8.
3/8. 6 7/8 to 7 1/4.
6 1/4
Oh, 6 1/4.
and 6 7/8.
That's totally different than we said.
Yeah, what did you
7 1/8, but right?
7
6
1/8 and 6 1/4?
6
1/4 is 7/8.
6 1/8 and 7 1/4.
6, 7/8.
That's inch and an eighth.
An inch and what?
An inch and 1/8.
Did you say 7 1/8
No, it's
and 6
1/4.
1/4?
6 1/8 to 7 1/4.
No, no.
Right, so you're right. It's
Oh, he said 6 1/8? I thought you said
6 1/8.
It's changed.
Yeah, it changed 4 times. What's the numbers?
But the
6 and what?
6 1/8.
Check it.
the last thing he said.
7 1/4.
I'm sorry. It's actually 5 5/8.
And what?
5 5/8.
I'm gonna write this down.
5 5/8 and 7 1/4.
Well, 5 5/8. There's another 3/8 there. 6 1/4.
2 inches minus 3/8.
Inch and 7/8. Should be.
5/8.
Inch and 5/8?
Inch and 5/8.
Okay, inch and 5/8.
What is it? I'll write it down and I'll figure it out.
Right here. Well, if it was 5 1/4,
5 1/4, and what was the other one?
It's 5 5/8 to 7 1/4. That would be
5
two
5/8.
inches.
Say 5 1/4, right?
2 inches
And what
minus
was
the inch and
the
5/8.
7 1/4.
Yeah.
It's 5
So
1/4.
it's 2 inches. It's just a hair under 2 inches.
Or what? What are you figuring it out for?
7/8. There's an inch and 7/8 difference between the front and the back,
Okay.
I'll buy that.
right? Because it's
No,
7
but it's
1/4 and
5 5/8.
no 5 and. Did I say 5 5/8? I'm getting confused now.
It's higher in the front than the back.
I thought you said fried eggs.
That works.
5 1/2.
5 1/2. Now, come on.
Hey, listen. Here, check this coat. What does this say right here?
We're gonna be down in the forest soon.
We're at 5 1/2.
5 1/2. Over here?
Okay.
You're at 7 1/8.
5 1/2 to 7 1/8 is inch and 5/8.
Hi everyone. Now that you kind of get the importance of metric conversions, why do we need to work with metric units? And I know this is small, so I'll read it to you, but it allows us in chemistry to answer lots of questions like, how much energy does it take to start a reaction? How will the volume of a gas increase if I heat it? How long will a reaction take? How much substance can a reaction produce? How much of the reactant is needed to produce a required amount of product? How much energy does a reaction release? How high will the temperature of the solution get as a reaction occurs? So these are all examples of questions that we could answer using metric conversions, and then later on, because these are kinds of fancy questions, we'll use something called the stoichiometry roadmap to answer these questions. But let's start with the easy ones. Here, first of all, are metric prefixes, and hopefully you remember this from physical science, and you had metric prefixes which allow you to figure out the quantity of something, as opposed to the base unit, which tells us about what it is we're measuring. So here are a few of those prefixes. Let's start here at this prefix centi, and you know that I could have a base unit of 1 in there somewhere, but a centimeter, for example, here's my meter part, a centimeter is 0.01 of a meter, which means it would take 100 of those units to make 1 meter. And I know that's a little confusing, but think of it like you would with pennies, where it takes 100 pennies to make $1, therefore each penny is 0.01 of a dollar, or 1/100th of a dollar. So think about it that way. A micrometer is 10 to the minus 6 meters, which means I would need 1 million, or 10 to the 6th, micrometers to equal 1 meter. And nano is the prefix for a billionth, and that would be 10 to the negative 9th meters. A picometer would be 10 to the minus 12 meters. You get the idea. And pay attention here because this, this prefix micro is related to this prefix mega up here. What's the difference? This is 10 to the 6th. In other words, a megameter is a million meters. So let's actually practice a couple of these. So I have 5.2 centimeters. And what do? We always write down what we know. And in this problem, we know we have 5.2 centimeters. The question is, how many millimeters is 5.2 centimeters? And you'll be doing lots of these practice sets if you haven't already. And you know they give you the answer there, so you can use that to check how you did on the problem. And maybe I don't know how many millimeters are in a centimeter, but maybe I do know how many centimeters are in a meter. And what I want to do is set my statement up, because really 100 centimeters is 1 meter. So I could set this statement up like 1 meter is the same as 100 centimeters, or I could say 100 centimeters are the same as 1 meter. So what I did then was I took this statement, 100 centimeters equal a meter, and set up something we call a dimensional unit. And I have 2 dimensional units right here, these 2, and they both mean the same thing. But what I want to pay attention to is this centimeter needs to go away and leave me with an answer in millimeters. So I have to figure out if I want to use this statement or this statement. So let's just say, for example, that I decide to use this statement. 100 centimeters is 1 meter. And I go ahead and I do my math. So 5.2 times 100, and I'm going to, if I multiply something by 100, I'm going to move the decimal over 2 places in this case, and my answer would be 520. But let's look at what happens to my units. A centimeter times a centimeter equals a centimeter squared, doesn't it? And this didn't go away, so that would look like that. A centimeter squared over a meter. And that doesn't make any sense at all. So therefore, that's definitely not the statement that I want to use. So let's get rid of that. First of all, 5.2 centimeters. And let's see if I can get myself to meters. There are 100 centimeters in 1 meter. So I'm using this statement right here. And that's going to make those centimeters cancel and go away, which is what I want. And it's going to leave me with an answer in meters. And so I would get point. If I divide anything by 100, I move the decimal 2 places to the left. So I would get 0.052 meters. Am I done? No, what's wrong with this picture? I need my answer in millimeters. So I've gotten myself to the base unit, and that's a good thing. So let me try and go from there to millimeters. So I have another statement. I have 1 meter is 1,000 millimeters. And I could turn it upside down if I needed to. 1,000 millimeters is 1 meter. And again, I would have the same problem as I did before if I pick the wrong unit. So this unit is one choice and this unit is the other choice. And which choice do I want to make? I don't want to make that one because that'll leave me with a meter squared over a millimeter, and that won't make sense. But what if I say 1,000 millimeters is 1 meter? Then those will cancel. And I'm going to move my decimal. When I multiply anything by 1,000, I move it 3 places to the left. So I would go 1, 2, 3, and my answer would be 52 millimeters. And you can put that in a calculator and check that if you want. So that's the long way of doing it. Let's do this in one single step. And I know you can do this in many steps, but let's just do it in one step. So let me get rid of a lot of this junk. 5.2 centimeters. And I'm looking for millimeters again. Okay, I know that there are 100 centimeters in a meter, and that's great. That will get me 2 meters, but remember, I want my answer in millimeters. So I'm going to multiply it by that other conversion factor, which I had before. And you'll notice here that that meter is on the top, and I want my meters to go away, so I better put it down here. I also know there are 1,000 millimeters in a meter. Okay, and I can check if I set this up properly, because my centimeters go away, my meters go away, and ta-da, I am left with units of a millimeter. So what I'm going to do in my calculator is I multiply all numerators. So in my calculator I put 5.2 times 1,000 over, I hit that divided by key, that little divided by key, over 100, and I hit enter, and I should definitely get 52 millimeters when it comes out. Okay, so this might look familiar to you. Again, the same question, how many millimeters is 5.2 centimeters? This way, then do it this way. So in this box, you would write 5.2 centimeters, and you know that you want your centimeters to go away, then you know that in that opposite box underneath, you want your centimeter value. And there are 100 centimeters in a meter, and I know I want my meters to go away. So in this box, I would put my meter. And I know 1 meter is 1,000 millimeters. And it's the exact same problem that we just did. It's just set up a little differently. And if you remember that you're just going to multiply all the numerators and divide by all of the denominators, you'll be in good shape. Let's come down to this next question and give it a try. It should be a little better for us. 1.6 milliliters of ethanol in microliters. So how many microliters are 1.6 milliliters of ethanol? So 1.60 milliliters of ethanol. And we have a special symbol for ethanol that you'll get to know. We use a capital E, lowercase t, capital O, capital H for ethanol. And this little unit here is an alcohol, and the ET prefix refers to the fact that there's 2 carbons in an ethanol. Anyway, no big deal. You'll figure that out later. So here I have my 1.60 milliliters ethanol, and I need to get it to microliters, and I do know that there are 1,000 milliliters in 1 liter, and I also know that 1 liter is 1 times 10 to the 6th microliters, and that funny looking thing is the Greek letter mu, and it's pronounced mew, just like a kitty. And if I do that operation, my liters will cancel, my milliliters will cancel, and I will be left with a unit in microliters. So in your calculator, you're going to put 1.6 times 1 times 10 to the 6th divided by this 1,000. Hit enter, and you should get 16 microliters as an answer on your screen. Sometimes you don't. But let me tell you something here about your calculator. If you didn't get 1600, which happens sometimes too, here's what you need to remember. So in your calculator, you can go ahead and punch in 1.6 and then times, and then what you're going to need to do is put a parentheses, hit the parentheses key, enter 1 times 10, and then way up there below the clear key is something we call a caret key, 10 to the 6th, end parentheses, over, so divided by, you put in your calculator, divided by 1,000, hit enter, and this time you should get 1600. Okay, so you just have to be careful that when you have exponents in a numerical statement like that, that you need to put them in parentheses and separate them, isolate them by themselves. Okay, so that's how we do that. Here's that same problem again with that different format that I just showed you. And so 1.6 milliliters, let's try our new method with this chart. 1.60 milliliters. And again, milliliters are going to have to be down here to cancel. That puts my liters up here. And so I'm going to put a 1 by the bigger unit, which is a liter. And I remember milli is 1,000th. So there are 1,000 milliliters in a liter. And I want my liters to go away. So I'm going to put a 1 by the bigger unit again and realize that in order for those to go away, they have to be opposite themselves on this grid, and that there are 1 times 10 to the 6th microliters in a liter. So those units will cancel, and I will be left with an answer in microliters, and I'm going to punch it in the calculator just like I told you to.